Hi, this is Mrs. McTaggart. So this video is looking at those weird and wonderful kind of bracket questions at National 5. The ones that are not just basically 2 brackets or a 2 and 3 bracket expansion. They have started to put in some miscellaneous ones. The one in the recent exam, 2025 exam, was a bit different as normal as well. So here are the examples. So we have x plus 7 all squared. This was actually in, what year was it? This was in the 2023 exam, and then 2025 they did something weird as well. So we have a bracket squared plus another bracket. Now the minute you see a bracket squared, what you should be doing is rewriting this out. So we should be rewriting this as x plus 7, x plus 7. And then I'm just going to leave that other bracket as it is just now. Right, what you do is you kind of treat this like 2 separate questions. You do the left-hand side, you do the right-hand side, then you tidy them up. So multiplying out your first bracket, we'll have x times x is x squared. You'll have x times 7 is 7x. Then you'll have 7 times x, there's another 7x. Then 7 times 7 is 49. Then this bracket on the right has to be multiplied by 6, giving you 6x squared minus 60. This takes up an awful lot of room. Then when we tidy up, so let's look at our x squared. There is an x squared plus another 6x squared. So 1 plus 6 is 7x squared. For your x's, you've got a 7 plus a 7, so 14x. And then you have a 49 take away 60, which gives you minus 11. There you go, 3-mark question. Here is a This one is very similar, only it's not a squared bracket, so we can go straight to multiplying the brackets. So this was 2018, this one was asked. So if we times out the brackets, 3x times x is 3x squared. 3x times minus 1 is minus 3x. 1 times x is just 1x. I'm not going to write the 1 though. 1 times minus 1 is minus 1. And then we're going to times out that second bracket by positive 2, which gives us... Oopsie daisy, gives us plus 2x, and then 2 times 5 minus 10. Right, tidy up part. So our x squareds, we only have a 3x squareds. Our x's, we have minus 3 plus 1 plus 2. So that's just minus 3 plus 3. So the x's actually disappear here, so there's no x's, so you don't write anything. And then minus 1 and a minus 10 give you minus 11. So I quite like that one to show you that sometimes a letter does actually disappear. Okay, so let's make it a bit trickier. How do we make it trickier? We put a negative in front of that second bracket. Now this one is actually a lot harder because there's also a 4 out the front here. So we're going to first of all rewrite this question as 4, and then we're going to write this bracket out twice. My writing's not great today. Okay, so there we go. Now we have options. Do we multiply one of the brackets by 4? Or do we square out these brackets and then multiply by 4 at the end? Which I think is what I'm going to do. So I'm going to leave this 4 here with a big old bracket. 3 times 3 gives me 9a squared. 3 times 1 is minus 3a. Then we have another minus 3a. Then we have minus 1 times minus 1 giving me a plus 1. Now watch this bit. It looks like there's nothing in front of the bracket. Remember, there's really a minus 1 there. So we're multiplying by minus 1. So this is going to become minus a and then minus 1. That's where mistakes happen. Then I need to times this other bracket through. I forgot to close my bracket there. I need to times this through by 4. So 4 times 9 is 36a squared. I probably should have tidied these up first. That gives me minus 6. And then when I times it by 4, I get minus 24a. Then I get plus 4. Then I get minus a minus 1 again. Right, tidy up. There's only the 36a squared term. I have got minus 24 minus another 1, which is minus 25a. And then I've got 4 take away 1 is 3. So there's my answer for that one. Right, let's see some bracket text now. So here is a lovely area question. Quite often at National 5 you have the part of like a really tricky question involves some bracket work. So what we're going to do is we're going to go back to first year and think, right, I used to ask you to people to do area this shape, but we had numbers on the sides, and our method would have been should have been the outside take away the inside. What's wrong with my writing? I've got a really bad pen today. So we would do outside take away inside. So the outside area would be, I can't see that number, x plus 3 bracket x plus 5. So I'll have x plus 3 bracket x plus 5. And then I'd take away the inside one, which is going to be x plus 1 times x minus 2. So I'm going to just move a wee bit of space over. So x plus 5, x minus 2. So x plus 5, x minus 2. Okay, let's expand this out. So first bracket, x squared. Then 5x. Then 3x. Then 15. Now, be careful. There is a minus 1 out the front here. So actually what I'm going to do is I'm going to leave this as minus and put in a bracket. I've run out of space, so then I'll have x squared minus 2x plus 5x, and then I'll have negative 10. I'm going to tidy these up. So we have x squared plus 8x plus 15. That's outside. Then we're going to take away the inside. So that's x squared minus 2 plus 5 is 3x minus 10. Now, I have to take away each of these things individually, or essentially multiply this second bracket out by minus 1. I can do it in 2 steps, or I can do it in 1 step. Let's do it in 2, just to show a wee bit extra work in. So we have the first bit's not being touched just now. So x squared plus 8x plus 15, right? So this is a common mistake quite often at higher as well. We have to take away each thing individually, or essentially multiply everything by minus 1. So that becomes minus x squared. This becomes minus 3x, and that becomes plus 10. Common mistake is we only take away the x squared, then we add 3 and take away 10. Everything is being subtracted or multiplied by minus 1. Right, tidy up now. X squared minus x squared, they've gone. 8x minus 3x is 5x. And 15 plus 10 is plus 15. Now, at National 5, normally there would be another wee bit to this question, but that's all I'm doing just now. This is tricky. I am showing some really... what am I saying? I'm showing some real extension work here. Right, I have got a couple more. This one here, we have a right angle triangle and we're asked to find x. So how do we find x? Well, right angle triangles involve Pythagoras. And good old Pythagoras said that c squared equaled a squared plus b squared. So that's how we're going to start this question. But we're going to write it as x plus 3 for our c, all squared. We're going to write it as x minus 1, all squared for our a, plus 8 squared. And then this gives us x plus 3 equals x minus 1, and then plus, let's just change that to 64. Right, expand our brackets. So we have x squared plus 3x. I'm going to cheat now and maybe take that to a 6x. And then 3 plus 3 is 9. Then we'll have x squared. We'll have minus 1 is minus 2x, plus 1 plus 64. Now, if I tidy this up, I can start tidying up here. So I'm going to subtract x squared from this side, which means subtracting x squared from that side. So do you notice that just becomes 0? So the x squares literally disappear. So they've gone. And I'm left with 6x plus 9 equals negative 2x plus 65. Add 2x to each side. 8x plus 9 equals 65. Subtract 9 from each side. 8x is 56. 56 divided by 8 is 7. So the missing side was 7. And in actual fact, if I go back to the original question, if x was 7, that made that side 10. That made that side 6. And that made 8, which is a really common Pythagorean triple triangle, 6, 8, 10. So this is tricky, but Pythagoras does sneak in sometimes. And then sometimes that third side has also got a bracket in it as well. I have one last example, right? This is not really asked at National 5, but I do like to sometimes push pupils. X plus 4 all cubed can be written like this. Now, our multiplying out bracket method does not work on 2 brackets, so what we're going to do is we're going to leave the first bracket as it is. We're not touching it. But we're going to multiply out this one. So we will have x squared plus 4x plus another 4x is 8x. 4 plus 4 is 16. And then it just becomes like a lesson, a previous lesson. We multiply everything out by x, giving you x cubed, 8x squared, and 16x. Right, to show you what I just did there, I did that times that times that, and that times that. I multiplied everything by x. Now I'm going to multiply everything by 4, which gives me plus 4x squared, plus 32x, plus 64. And then my layout helps you tidy that up. So you get x cubed, plus 12x, plus 48x, plus 64. So this is a purely extension work, but some of those earlier questions are definitely sneaking into the exams. I hope this has helped. Thanks so much for watching.